Okay, let's dive in. We've got some fascinating material from a listener
Oh,
here.
yeah.
Yeah, it takes us into a really specific real-world challenge.
Okay. What's captivating, for me anyway, is seeing how these sort of abstract math ideas,
Like calculus.
exactly like calculus concepts, how they become really essential tools for, practical problems.
Right. And this material points towards forest resources technology specifically.
Mm. Interesting field.
So yeah, this deep dive is all about applying differentiation and maybe especially integration
Okay.
to a very tangible task, figuring out the area of forest plots.
Ah, right.
Our mission, kind of based on the source material you sent in, is to understand how these, mathematical heavy hitters get used when the land isn't just a nice, neat square or circle.
And let's be honest, it rarely is, right?
So actually,
Especially forestry.
definitely not.
You get boundaries following rivers or like weird terrain, maybe just clumps of trees defining an
Yeah.
edge. Your standard geometric formulas, they don't cut it for those kinds of messy, curvy boundaries.
So this is exactly where calculus steps in, offering a powerful alternative.
Right.
We often think about differentiation for rates of change, how steep a slope is.
Instantaneous change.
And integration, fundamentally, it's about adding things up, right? Summing up tiny pieces to get a total, area under a curve.
Precisely. So if you map out that irregular forest boundary,
Okay.
you end up with a complex line or maybe just a set of survey points that don't fit a simple equation.
Right. Not y equal m plus b.
Not usually, no.
Yeah.
And the challenge is finding the area inside that boundary. That's where integration really shines. It lets us find the total area even with these non-standard shapes.
Okay, but how do you actually do that? With a real boundary that's just points on a map, survey coordinates, it's not a smooth function from a textbook.
That's the key practical step, yeah.
Mm-hmm.
That's what the sources get into. Foresters or surveyors, they aren't finding some perfect mathematical function for the boundary. They walk it. They collect data points. Yeah, X, Y coordinates, basically, at different spots along the edge.
Right, like connect the dots almost.
Sort of. And calculus, specifically methods of numerical integration, lets you use those discrete points to estimate the definite integral, to estimate the area.
Ah, numerical integration. Okay, so you're not finding, the perfect symbolic answer by integrating some clean formula.
Not always, no. It's more about using techniques.
Mm.
Maybe you've heard of the trapezoidal rule or Simpson's rule.
Vaguely, yeah. From calculus class, maybe.
Right. They work by breaking down that irregular area under the curve or between the points into lots of small, simple shapes, like trapezoids.
Okay. Shapes you can calculate the area of easily.
Exactly. You use those collected survey points to define the edges of these little trapezoids, sum up all those small areas.
And you get a really good approximation of the total plot area.
A very good one, yeah. Numerical integration gives you the framework for that summation. Differentiation might still pop up, maybe analyzing terrain slope along the boundary for erosion or access.
Sure, okay.
But for nailing down the area itself, numerical integration with that survey data is like the go-to method.
That makes so much sense. It takes something really messy, like a natural boundary.
Yeah, jagged.
And applies this rigorous math process to measure it accurately. It's the difference between just guessing and, properly quantifying the land for management or conservation.
It really shows what calculus is for, doesn't it?
Mhm.
Moving beyond perfect shapes to actually analyze the complexities of the real world.
Yeah.
Those integrals aren't just symbols on a page. They translate directly into things like acreage, practical measurements.
So wrapping this up then, the listener's material highlights a really compelling use case for calculus.
Definitely.
Specifically, how integration, often done numerically, like summing up trapezoids from survey points, is essential for accurately measuring those tricky, irregular forest plots.
The ones that simple geometry just can't handle. It shows calculus isn't just theory. It's a practical tool, a necessity, really, in fields like forest resources technology. Gives them the precision they need.
Absolutely. Okay, so here's a final thought for you listening. If calculus is key for measuring weird shapes in forests, where else do you see that?
Good question.
Think about other places in nature, or maybe in fields you're studying or working in. Where do you run into complex, non-linear shapes or amounts that you could only really measure or understand using these same kinds of mathematical tools?
Yeah, maybe like mapping a coastline accurately.
Hmm.
Or figuring out the volume of some weirdly shaped rock formation.
Or even analyzing how water flows through bent pipes, or looking at the area under curves in, data analysis.
The applications are pretty much everywhere once you start looking, aren't they?
They really are. Something to think about.